Let's solve step-down autotransformer template, which consists of primary winding and secondary winding. So the key to make this transformer an autotransformer is to connect properly windings with the source and load. On the left side, we see a voltage source, we see the primary, secondary windings, and the load. Because this is a step-down autotransformer, we would expect that the current that flows through the secondary and primary windings will combine and run through the load. In order to set up the circuits, I defined the positive terminal for the voltage source and primary winding as 20, as a negative terminals for voltage source, secondary winding, and load will be 0 or ground, and the common node where primary winding will connect with the secondary winding and win the load, I will define it as a 10. You can choose those indexes 20 and 10 arbitrary, and the only purpose of those indexes will just tell the circuit builder how those individual parts of the transformer or those components are uniquely connected with each other. So unique indexes that are common for multiple components will indicate to the circuit builder that they are connected. So let's go back to the circuit builder in TRAFOLO. So 20 and 10 for the primary winding, 20 and 0 for the voltage source, 10, 0 for the secondary winding, and then 0 for the load as well. So once the simulation is over, which takes about like 15 seconds in this case, head to results graphs section, and here you will be able to take a look what is the amplitude current for the primary winding, for the secondary winding, and for the load. As you can see, the current, amplitude, and the load is a sum of primary and secondary. While if we take a look on the voltage, on the primary, on the secondary, and on the load, you see that the voltage on the primary is larger than on the secondary, while the voltage on the secondary is the same as in the load, which makes sense. So we solved an autotransformer case.